Good morning. Thank you so much for you to come today. It's an amazing conference. I hope you're having as much fun as I am having. As you say, I belong to this organization called the Concord Consortium. We are located in Massachusetts. It's a nonprofit in the United States. And we have been working in developing technologies for STEM education for 25 years now. And this work that I'm going to present today is just a small piece of a broader project called Code R for Math. It stands for Computing with R for Mathematical Modeling. It's a collaboration with Concord Consortium, the Clarkson University in New York, and the Boston Latin School, and it's founded by the National Science Foundation. So I don't have to tell you how popular R is among data scientists inside and outside of the academy. And I'm here today to show how we are managing to teach R to high school students in regular math classes. We are doing that using R as a tool to teach mathematical modeling. And for those of you who are not familiar with that, it's a major objective in high schools, not only in the United States, but in Europe, many other places. And one might ask why we choose to use programming to teach mathematical modeling and why we chose R. Well, first, R is a wonderful modeling tool, and good thing because that's why I'm here. But the most important reason is that we are trying to help students to develop a special thinking style during the math modeling learning process. And we call this learning style or thinking style, it's computational thinking. And computational thinking comes before coding. It's a collection of thought processes involved in formulating problems and their solutions, so that the solutions are represented in a form that can be carried out by an information process system. For example, a code that is run in a computer. Of course, this is a very desirable skill set and an excellent way to develop, to exercise this way of thinking is programming. So in US, for example, there is a number that is between 10 to maybe 25% of students that leave high school with some contact with programming language. And that happens for a number of reasons. One, their schools might not offer computer science classes, or sometimes their schools do offer computer science classes, but these students are just trying to put one foot in front of another. They are busy, they have other things to do, or they think because of their careers of preference, mathematics is not for them, coding is not for them. And to overcome these barriers, we are integrating computational thinking into the regular mandatory math classes. We propose to teach students how to create, visualize, and analyze mathematical models using R. So along with learning just how to code and solve real-world problems, they learn fundamental programming tools and concepts. The novelty for the high school habitat, I would say that's because we are using R as the modeling environment, which is something that you don't see in high schools in US. So our results are encouraging. I have to say that more than teaching just how to code, this experience of coding with a language that is so powerful, but it's so friendly, as R is, has helped these students to develop an appreciation for mathematical modeling and coding. Just keep in mind that we are aiming to the regular math student, not the one that's already enrolled in computer science classes. So these are kids with all sorts of interests and backgrounds. I would like to go to the next. Sorry. So if you bear with me, during the next few minutes, I will show you how the learning curriculum modules that we develop work with these students to tackle this challenge. And we're going to take a quick view on our pilot results and the strategies that made that thing work. So our pilot module was called Life Hacking. So it's just composed by like self-paced tutorials that challenge students to model solutions for practical problems like the cost of eating in college, or the real costs of owning a car, or choosing between careers, etc. So it was designed to bring open-ended problems that are relatable to someone that is moving into the adult life. The instructional sequence is this. They first play with a learning sequence, sequence of activities. And during this sequence, we gradually increase the level of sophistication for the modeling part, while we decrease the level of scaffolding for them. So we're going to see an example in just a bit. Just please bear with me. So after they are done with the learning sequence, we come with an assessment. And the assessment in our pilot case, we call that driving for gas. So we invite these students to write a model, to think about a model, to help a driver to decide where to go to fill the car tank when the gas light comes on. So we give them a very, very simple template code at this point, and we ask them to run the code and explain line by line what it was doing, and try to come with justifications of what the person that wrote this code had in mind. What were the assumptions? Which ones work? Which ones you think didn't work? How would you sophisticate or refine the code or the model as you wish? And try to implement those little things in the model. This is the kind of students that we had, is our sample. So 42 senior students on the second semester of the last year in high school. These students had the opportunity to follow computer science classes. They decided not to do for a reason or another. And according to their teachers, it's not me saying, their performance in mathematics were average or below that. They were taking a regular math class just to fulfill their math requirement for graduation. Almost 2/3 of them said that they wanted to follow careers in humanities or social sciences. So if you put everything together, we have a path that is leading these students out of any programming experience or mathematical modeling experience. And yet, they did very well in the assessment. They could explain every line what was doing. They came with very simple, I would say, but focused suggestions to refine the model. So they were able to create new variables and explain what they wanted to do in the model. They explained things about the modeling process and everything. They actually did great. And remember that the population that we have in hands, these students had no interest in coding before this activity, and actually they didn't appreciate mathematics very well for that sake. And yet, this is what we got. The first thing is that we had 6 hours of activity with these students, including the assessment, just 6 hours over a few days. And one of the things that we did is that we passed an exit questionnaire to them, and we asked them how they understand what mathematical modeling is, and if their understanding has changed before and after the exercise. And 80% of them say that now they understand mathematical modeling better, what it is and what it's used for. Of course, it's a self-assessment, but their answers, the answers that they came explaining what mathematical modeling is, they were actually understanding concepts. If not the whole thing, they were understanding concepts. And the cool thing here is that we got 1/3 of these students saying that they became interested in following computer programming classes. It may say like 1/3, but remember the population that we have, and 1/3, it's a lot. I find that like very, very good result. It's very exciting. So we built the tutorials using mainly R Markdown. I think that for everyone that was following, that we're following like workshops, we see how it works. And we use the Learn R package and Shiny to put everything online. So Learn R allows you to create interactive code snippets. So you can pre-populate these snippets. So a student that goes there, they can just run and see the output, but they can modify and see the output. They can create something from scratch, right? And it also allows us to preload all the data set that they are going to use. So remember, those are beginners. They have never had a contact with that. We don't want to stress them with downloading the data, finding the right format, etc. Just open the thing. Let's start exploring the data, right? So what we have, as I say, is that the tutorials are self-paced with step-by-step clear instructions. We know how it works. The snippets created with LearnR tools, so students can simply run or modify and rerun. And also they can see the results on their page. So I wanted to show just briefly, give a quick look on the pedagogical strategies that made the experience work. The first thing, the most important thing, is that everything is taught in the context of the initial problem. So students learn concepts and tools only when they need to use them. So that gives them motivation to learn something new. So you pose a question and you teach them a tool to use that. So in the pilot learning sequence, they were invited to wear the shoes of a college advisor that has to help college students to decide between buying a meal plan offered by the college or paying out of the pocket on a per meal basis. So they come with brainstorming and trying to decide for new parameters, what are important and what are not important, and they start building an algorithm before coding anything. But they have an idea on how that's going to work, and now they want to test the algorithm, and now they want to learn how to put that in a code. And when they reach a point that their code is simple but functional, we come with more complications like, oh, okay, so you found the costs of eating for your client, right, for a semester, but what if they are not going to school every day, right? What is the impact of a day off campus, or 2 or 3 or 4? So they quickly realize that they can check case by case, but if only we had something, we could invent something that would take care of several cases at once, and then you teach them, oh, there's this thing, that is entity here called a vector, and then you tell them how do you operate with them, that every element is unique, and so on. So they learn when they need. And so the second strategy is faded scaffolding. So first, we offer like a full script that they just have to run. That's high scaffolding. They run, see the output, great. They don't have any stress with syntax, anything. And then the median is scaffolding. We ask them to modify a thing or two in that snippet. Now, change the color, put another limit, add this other thing here. And low scaffolding is when they have to create new parameters, they have to build another equation, things like that. So it works. The cool thing is that it works, and it works very well for us. We are pleasantly surprised with the percentage of students who say that they became interested in taking programming classes after the pilot program. At a third of the students, a very good number, and that was a population about to leave high school that decided not to take computer science classes whatsoever. If they didn't have this experience, they would probably, in their adult lives, never see something like that or appreciate that. And we are talking also about students that are the humanities inclined students, as I said. Teaching everything in a context and reducing the syntax stress were key to encourage these students to give a chance to programming language. And this is what we are doing now. We are integrating the web-based R into a full-featured learning management system, and this is how the platform will look like in a couple of weeks, hopefully. It is, the whole thing is both an educational and research-oriented platform. So it's possible to record the data for learning science research afterwards. We have protocols in place for data security, data anonymization, and everything. And last but not least, if you have any material that you would like to see delivered to your students under a platform like that, we have 24 years of knowledge of building this kind of thing, and we would be thrilled in working with you, not only high schools, but any level. And thank you very much. If you have any questions.
Thank you, Kenia. And any questions?
How do we get high school teachers interested in this?
Sorry, come again?
How do we get high school teachers interested in this? How do we get
how teachers? Okay, the teachers that we work with in this pilot students, they were thrilled too. They say that they try to come with questions, for example, like, oh, this is something like mathematical modeling. They see that at school, and they say, this is your textbook case, right? So this is a small scale, and then, but the life is different when you're out there. How do you see that? How do you see that? This is the kind of platform that's useful because we have support for teachers too. They can have like a sort of script on the side. How do you suggest to do things? One of the things that we worked with some teachers before going into the classroom was to build some codes in R. And I asked those teachers to run that code. They didn't know R yet, but to run the code and see what it was doing, like the same as his assessment, a little bit more sophisticated. And this one teacher came to me and said, I thought it would be impossible because I don't know R. I'm not a programming person, but I did. I saw the output. I knew exactly what it was doing, and I could just change things. So I could just copy, paste, replace, and it worked. So they were excited about that too. Did I answer? Yeah, kind of.
Any more question? Okay.
First of all, thank you for the amazing presentation. I'm in the process of developing several tutorials for a public policy school at a university, and we're actually looking into using LearnR and Shiny. So I was wondering if the materials that you talk about, is there code available online? And if so, I went to the GitHub organization and there are 300 repositories, which is amazing. But I was curious if there's any direction.
Yes, I can give you the directions because that platform that I showed here, the cool way, the cool looking platform, people are developing that as we speak. But I can give you access to the pilot platform. I can give access to all of you. And it's going to be available to everyone. I mean, it's open. It's supposed to be open there for to improve the reach. I mean, we want to reach everyone.
Okay.
Does it? We can talk together.
Oh, thank you.
Thank you.
Thank you very much.
Thank you again.